welcome everybody to today's third and final webinar series of the iHub Summit. My name is Marie Karekwa, ERA's Engagement and Program Coordinator. Before we get underway, I'll just do a little bit of housekeeping. If you guys have any questions throughout the presentation, please use the Q&A chat function that's located just at the bottom of your screen, and we will allow some time at the end of the formal presentation for some Q&As with our presenters. I would now like to pass things over to ERA's Chief Executive Officer and the Chair of the Innovation Hub for Heating and Cooling Steering Committee, Tony Gleeson. So thank you, Tony.
Hello, Marie, and hello, everyone. My name's Tony Gleeson. I'm the two things. I'm the actual Chief Executive of ERA, but more importantly, I sit as part of the ARENA steering committee that oversees this project. It's important to understand, I think, that this is multiple stream projects. We currently have 16 projects in operation, and today we're going to hear about the Data Clearinghouse webinar. And with a whole lot of other, we're going to hear about the Living Labs today, but we've also covered off the Data Clearinghouse. We've also had the Integrated Design Studio webinar in the past period of time as well. Before we begin, I'd just like to recognise the traditional owners of the land, which we all meet throughout Australia. We want to recognise their continuing connection to both the land, the water, the community. We pay respects to them and their cultures, to their past, to their elders, both past, present and emerging. I think that's important to recognise where we're part of as we drive to really try to achieve some of our goals. We're part of a bigger world at this time, and we really should need to recognise that. As we move forward, I do want to recognise that the funding for this project has been received through the ARENA's Advancing Renewables program. Without this funding, these projects would never have got off the ground, and a very important part of what we do. So we thank ARENA involvement, and we're certainly contributing to that space, of which is looking at the renewable energy space as well. All these webinars, by the way, are being recorded and will be available on the Innovation Hub website. You can find out more about there at www.ihub.org.au, as well as what will also be available there are the various lessons learned reports and update reports that are continually created through this project. By the way, this isn't really a one-off. We're going to have a number of summits throughout the year. The next one's planned for in November, and more information will come available then. Hopefully when the country opens up, people will be able to attend in person and be able to engage with the people directly. Before I hand over, the iHub project is still open for projects. We've just had 4 new ones added to our list, and there's those opportunities. You can either contact myself or you can contact via the Innovation Hub website to find out some more information. So with that in mind, I'll hand back to you, Marie, and onwards with Aaron and the team looking at our Living Labs.
Thanks for that, Tony. So Aaron, I might pass things over to you now, and you can get us underway. Thank you.
Hello, everyone. I'm Aaron Leung from Queensland University of Technology, Brisbane. I am the project manager for Queensland Children's Hospital Living Lab. Before I start, that I can mention our presentation, the QUT part, is about 30 minutes. Then we'll be followed by our University of Wollongong team presentation for the remaining 3. That'll be another 30 minutes. After 1 hour presentation webinar, we'll have a Q&A session. So please keep your questions to then, or please leave your questions in the chat functions or Q&A sections later. Thank you. Okay, here is an overview of our iHub Living Labs. In total, we have 6 Living Lab streams. Is starting from the healthcare sector-wide activity on the left, moving on to the Queensland Children's Hospital Living Lab and the Fernhill and Bolton Clark Residential Aged Care Living Lab. That's Sherif. Dr. Sherif Zedan is the project manager for the Fernhill site. And then Warrigal Care and ACT schools and the education sector-wide activities are managed by our colleagues Georgios and Clayton. Okay, so let's start with the healthcare sector-wide activities first. Why we do this project, or how important it is. Globally, that 4.4% of net emission comes from healthcare, and 29% of this emission directly related to care facilities and vehicles. And we can see that on the chart on the right, 40% of this emission comes from generation and distribution of electricity, gas, heating, and cooling. Let's move on. That's in terms of top 10 healthcare emitters. In terms of healthcare, by countries or by regions, that's the United States, China, European Union are the top 3, and Australia is number 10. If we talk about the total emitter in terms of countries, it will be China, US, and European Union. And this visually shown on the right-hand side diagram. So that's United States, China, EU. We are about number 17 in terms of the total emission by country. If we talk about healthcare emissions per capita by country, we are on the top of the list. So top emitters over 1 ton per capita. Australia, Canada, Switzerland, and the United States are the top. And there are other countries on the list. So how do we measure hospital or healthcare, the energy or emission performance? We may use a range of KPIs. For example, energy use intensity, that's EUI, per floor area, and we have different statistics from UK, from Wales, from Scotland, from USA. And we also can do EUI per full-time staff, or per staffed bed per square meter, or per floor area correlated to cooling or heating degree days, or per MRI per square meter, because MRI actually is a quite big power consumer. If you look at the US, 2012 healthcare building energy sources, this is on the left, is about the energy sources. 51% of the energy sources were from electricity, then followed by gas and fuel and other district heating. But on the other side, if you look at the end-use breakdown, the top 3, so 29%, 12%, and 11%, that's number 1, 2, 3, are contributed to space heating, ventilation, and cooling, so HVAC. Together are the number 1, or 1, 2, 3. On the other side, that if we use a kilowatt hour per square meter as a KPI, it has some limited usefulness. For example, if you look at US, Wales, UK average, and Australia regional public hospitals or capital public hospitals, we can see it's quite a big difference globally, from about 100 to about 1,500 kilowatt hour per square meter. Also, there are many other reasons contributing to that. Climate reasons, age, energy efficiency of the buildings, infrastructure, equipment, degree of medical specialization, building sizes, national or regional healthcare budgets. So they all contribute to the variation. Here's a chart to show 100 hospitals energy profile for 4 climate zones in China. So we can see that in hot areas, that in the summertime, energy goes up in the summer month. In the colder areas, that energy goes up, consumption use goes up in the winter months. Quite reasonable. But on the other side, if we go a bit more by departments, by the functions, then we can see on this chart, the blue charts are the base load, watts per square meter, and the orange charts are the peak load. That's watts per square meter, but it's for the peak load. The gray bars are for the load factor, the peak divided by the base. We can see that the top 2 are theater average and the laboratory average for the base load. And also for the peak load, that we have the theater average and also laboratories average. The same pattern appears on time of use. This is another chart to show time of use energy. So the blue bars are for the all days energy consumption, energy use per square meter per day. Orange are for weekdays. The gray bars are for the weekends. And the yellow bars are for the ratio weekday divided by weekends. The same pattern appears that the theater and the laboratories have quite high time of use for all days and for weekdays and weekends compared to other different functions. If you look at healthcare trends, generally we have 4 types. For example, first one is we tend to have a blurring lines between facilities. So now hospitals may not just be hospitals. There is has medical function, it's for surgeries, and it can be allied health hubs, for example, for regional areas. And or another way is that, do we keep hospitals for critical specialized care and moving towards more kind of moving into a home care or local clinics care model like Denmark? They've been trying to reduce the number of hospitals rather than increase the number of hospitals. Technology, we have more energy intensive medical diagnostic equipment. And on the other side, we have more energy building technologies or services. And the electrification is another trend. One thing is, for example, electric transport for on-site or not far distance transport for patients, for ambulance. And another thing that we're looking at is about the electrification of boilers in hospitals or healthcare facilities. Replace the gas boilers with electrical heat pumps or other electrification technologies. So here is some statistics about 100 care homes in European Union. In Europe, they call it care homes. Here in Australia, we may say aged care or retirement villages. So in terms of energy sources, we can see that natural gas is quite popular, and we have fuel, electricity followed by. 4 energy use intensity indicators are examined here. You can see it's kilowatt hour by meter squared per year, or by resident, or by square meter, or by heating by resident per year. The mean value is in the middle column on the bottom chart, but the range is on the right-hand side of the bottom chart. We can see that one thing I learned from this chart is there's a big difference, or the standard deviation can be quite high, ranges quite differently. For example, if you look at the second row, it ranges from 2,000 minimum to about the 36,000 maximum in terms of the EUI number 2, kilowatt hour per resident per year. If you look at Australia, New South Wales government did some study for 15 aged care facilities in New South Wales. So I found out that heating, cooling, that's 44% of the energy use. It's number 1. And Tasmania did a bit of auditing of about 9 aged care facilities. Generally, they have quite a similar trend for the 1, 2, 3. For the first 8 facilities, the last 2 are a bit high. Reasons are not reported. And we studied 80 units aged care in Southeast Queensland based on its 2016 data. This is one case study. We have more in the following slides. We can see that in our Southeast Queensland climate, that for example, in the winter, that's the blue dotted lines, we tend to have double peak. That's average power is kilowatts. That's how fast we're consuming electricity. So we have double peak in the morning, which is called morning, and then in the evening. But on the other side, in summertime, the orange line shows that the morning peak did not appear, but we had a high evening peak. Similar thing can be reflected in terms of energy use. If you look at independent living units by month, we can see that for the hot month, we tend to have more electricity use, and the cold month, we tend to have more electricity use. But for the mild seasons, like the spring or the autumn, we tend to have lower energy use. In terms of peak, it's similar, like peak happens how fast we use electricity. We use electricity faster, or we consume electricity quicker in cold month, winter, and hot month, summer. For example, air conditioning, and milder in the mild seasons like summer, in the autumn or spring. Here's another two charts from another two sites, aged care sites. It can be quite difficult to see the legends, I suppose, and the tiny portions, but maybe more importantly, let's look at the blue bars on both charts. The blue bars are the same thing, air conditioning. So what can we see here? AC cooling is quite highly seasonal, varies, in the hot summer, and drops down to winter, and it goes up again as we are approaching summer. Similar pattern happens on the right-hand side as well. What we can see is number one energy use is air conditioning across the whole year. It's quite obvious. What can we do? So we are inviting technologies to be tested in our iHub Living Labs. For example, for our Queensland Children's Hospital Living Lab, we're looking at reducing building heat loads, HVAC efficiency, heating, ventilation, air conditioning efficiency improvements, optimization or predictive control in terms of the operation of HVAC. For example, precinct or offsite renewables. We have 5 stages process. We may have started with initial discussion and meetings. Then we have EOI forms documents. The links are available on ihub.org.au already. And then we have evaluation and agreement, reading, signing, legal process. And then we can conduct site installation and testing. Of course, some of the process may be iterative and repetitive. And the last step is analysis and reporting. And all reports will be made publicly available, except the background IP, the technology, of course. We also need to report, for example, the sector benefits, national benefits, if we extrapolated the technologies applied in our living lab. In terms of benefits, we may have energy benefits, economic benefits, environmental benefits, enhancement to the system. So that's 4 E's, and all these 4 can be categorized into societal benefits or network benefits or healthcare sector benefits. Our prospectus for each living lab have contained such information. If you are interested, please go to ihub.org.au. Now I'm going to start describing our Queensland Children's Hospital Living Lab before passing on to Sherif. So we have 3 buildings for the Queensland Children's Hospital precinct. The first one, the major one, is the main hospital, has 19 levels, 3 types of air conditioners systems, and we have some PAC systems in some non-clinical areas, like in the kitchen. Next one is the Center for Children's Health Research. It has 9 floors. 5 floors are for research labs, like for tumor bank, other quite high-level research. And the pathology services, COVID-19 test area on the ground floor as well. The main HVAC systems are CAV, VAV, and fan core units. There is a designated central energy plant. That's the picture shown here. There's 6 cooling towers at about 30 megawatts power capacity. Chilling water plants, in total is about 20 megawatts. Also, it has about 7 gas water heaters, and they're looking at replacing 1 or 2 into electricity or dual fuel boilers to improve security or say reliability. And then another 2 natural gas boilers, that's to make steam, and then stormwater treatment reuse, standby power plants, and also grid connection. That's 3 of them. It's kind of a N+2 redundancy. If we have 2 out, it's still okay for the whole site. Here is some energy use by month. The red bars are for the main hospital consumption. It varies a bit, but not much across the year. This is real data from last year. The gray bars are the energy consumption for the research building, CCHR, Center for Children's Research. However, what's quite obvious is the blue bars. That's for the energy plant. Mainly is, for example, HVAC, water heating. it goes quite down in the winter month and it goes quite up in the summer month. If you look at monthly peak demand, so the highest peak half-hourly kilowatt in a month, that for example, in last year, February, we had about 4,800 kilowatts registered. And in July last year, it was about 3,600 kilowatts registered. So that's how fast we're consuming electricity. And similar to the energy, but the rate of using electricity seems to be a bit slower in the winter month and higher in the summer month. After COVID-19, we tend to know more about, or a lot more people know about a flattened curve. So if we talk about the flattened curve for this, for the peak demand, if we change this in terms of the money value rather than kilowatt electricity or energy value, from here, top in February to the bottom in July last year, the monetary value is about $26,000 for a month. If we use $22 per kilowatt tariff, it depends on tariff, of course. So if we can flatten the peak, flatten curve, we can significantly have some good financial benefits. So as I mentioned, that we are looking for technologies to test at our Living Labs. My email is here, and here is a screenshot of the website, and the website ihub.org.au. Thank you. Now I'm going to pass on to Dr. Sherif Zedan to talk about our Fernhill Living Lab. Thank you.
Thank you, Aaron. Good afternoon, everyone. So my name is Sherif Zedan, and I will be the project manager for the Fernhill Living Lab. So this is the second Living Lab that we have in the iHub project. And it is a new building that will be built on an existing precinct for aged care. It is built for Bolton Clark. And the main building that we will be looking at is this one here as for stage one. As you can see, there are 3 stages, and this stage has been already completed, so it's due for commissioning, I think, in mid-August, and it should be occupied by end of October, I think. Now, the actual building was built, as I said, on an existing aged care facility. So all these buildings will be demolished, or they are actually now demolished. And the main reason that Bolton Clark was planning to develop this building is to basically fix some of the problems that the old setup had. So things like, for example, the old setup, you see that some of these hostels were a bit spread out, which made it difficult in terms of staffing, and in terms of also providing better care for the residents. The other reason is that the nursing home was basically designed as a ward with shared bathrooms. So it's Bolton Clark aim to provide better living quality and conditions for its residents. So the aim is to have en suites for all the bedrooms, so that there's no shared bathrooms. The main goals is for the building to provide a sense of home rather than institute to its occupants, to have good environmental design and better communication with the environment. So, for example, landscape, like views of landscape from the rooms, a lot of green areas for the residents to be involved with. Another aim is to have intergenerational relationships, so basically making the building also appealing for younger generations, integration with the community, and also providing flexibility in future changes. So that's in terms of the precinct, building, and the spaces. And also there's an aim to balance between the public and private in terms of zoning. So the building, the focus of our Living Lab is a high-rise building. It has 144 beds of residential aged care. So these beds are along 4 typical levels. So all of the rooms have en-suites. The rooms design are flexible, so in terms of furniture and in terms of also combining the rooms. So it is possible to combine 2 rooms into one if needed. So basically this is to give the occupants a sense of being in control, so being at their own home in essence. The residential facility has cafes and spas and library. It has reception areas and training in the ground floor. In the basement, there is a kitchen and laundry. There's also like spaces that are accessible to the general public, so cafes and retail spaces, so that in order to make the building more integrated with the surrounding community. So in terms of energy efficiency and ESD, so the building has a hybrid building design. So that's in terms of combining natural ventilation with mechanical HVAC. So each one of the rooms, they have operable windows. There are ceiling fans in each of the rooms. So that's also can be controlled by the occupants themselves. It's also hybrid in terms of lighting. So the building has like the normal lighting on and off switches, but there are also some lights that are triggered by motion sensors. There are some lights that use time clocks to set based on the occupancy and activity schedule. So basically what Bolton Clock will do is in the first few months, they will learn the patterns that the occupants use the building. And then based on that, they will assign certain times where the lighting are turned off. There are also some lights that use PE cells, so cells that respond to lux. So these lights basically respond to the solar light. So when it's in the morning, like in the morning, it's off, and then once the sun starts to set, it's turned on automatically. The building also has BMS, so building management systems. So it is possible to remotely control and also monitor the energy efficiency and the energy consumption of the building. The building is airtight, so it has 1 air changes per hour. And there is a provision for future renewable energy. And because the building is on an existing, or like it's on an aged care precinct, so there is also possibility of energy trading. The HVAC plant, so there are 3 chilled water systems. So that to allow for the different seasonality, it's possible to use only 1 chiller or combining with other chillers. There are chilled and heating water pumps. They all have variable speeds. There's chilled water storage, a heating hot water buffer tank, and variable speed secondary chilled water pumps as well. Okay, so in terms of the Living Lab itself, so we aim to develop a digital twin for the building. So basically we'll be building a digital model for the building that encompasses everything that the existing building have. So not only in terms of the building elements, but also in terms of the use and the activities. So we will be monitoring, for example, the activities and the occupancy schedule of certain zones, the lighting schedules and air conditioning setup and schedules for the building. So all of that will be reflected in our model. It's also possible to, what we're planning to do is also to have a model for the building services as well. So that basically the aim is that we can identify the impact that some of the changes can make on the building level in terms of energy efficiency and reducing energy consumption. So in addition to the digital twin, we also have specified certain rooms in the building to act out as our own lab on site. So the 6 rooms we chose them to be on different orientation to encompass the impact of the different orientation on the temperature and the lighting of the building, for example. So we have some rooms on the north, west, and east. We also chose the rooms to be sandwiched between 2 levels. So they have similar rooms above on the upper level and on the lower level. And the main reason that we did that is to see how would the impact of what we're testing in our living lab room on the upper rooms and lower rooms as well. So we have a range of sensors to reflect what is the existing situation. So, for example, we have temperature sensors, we have relative humidity sensors, we have carbon dioxide sensors, we have also sound and light sensors as well. We have reed switches to and control of the operable windows and the air handling units as well. So because as I said, the building is on an existing retirement village, it's likely that the occupants of that retirement village will be the same people who will move into the new building. So as a way to compare between the effect of just the building on the energy consumption, we have gathered data, or analyzed data from the existing retirement village. So this is here the annual profile. So that's the consumption per bed per day for a whole year. And because the activities are more or less the same throughout the year, so there's no difference in activities of the residents. So you can see here that this drop during winter time is more or less because of the air conditioning. So as Aaron also mentioned in the studies he showed earlier, it's the air conditioning also had the majority of the impact of the energy consumption. This is also supported by the other years that Fernhill site, the consumption of the Fernhill sites throughout the year. So you can see also a reduction in energy during winter time. This here shows the comparison between the peak summer day and peak winter day. So for peak summer day, you see that the peak during summer is higher than winter. And also the peak during summer is more or less during the hot part of the day, which also coincides with lunchtime. So it's possible that some of the lunchtime activities also contribute to that energy consumption. During winter, it is less, the peak is less, but there is a sudden rise during morning hours. Okay, so what are we hoping to test, or what are we aiming to test in Fernhill? So because the building is naturally ventilated, so we are interested in things related to adaptive comfort. So for instance, smart control of operable louvers. In terms of HVAC plants, we are interested probably in anything that can be retrofitted to existing plants to improve the efficiency and performance of HVAC systems. So things like water treatment, compression cycle efficiency, innovative heating cooling mechanism, etc. In terms of building envelope, anything that can be fitted into the building easily enough to fit and to remove, to improve the building envelope performance. So things like, for example, roof or wall coatings, smart glazing, internal, external shading devices, all that might be interesting to and possible to test. In terms of the building management system, things that can integrate with the building management system to optimize the building operations, so management of demand, load shifting, predictive maintenance, etc. Internal heating, things that can reduce internal heat. So, for example, smart lighting controls. And Also because we have a provision for renewable energy on site. So things like renewable energy storage and management, site trading, that all can also be beneficial to us. So if you have some technology that you would like to test, or if you know of some technology that might suit this scope, just contact me as an initial step with a brief of what is the technology is about, and then we will contact you. We'll have a meeting, and then we can go through the process. We are hoping to, or the aim is to actually try to finish the testing within the next maybe 4 to 5 months. So the sooner that we get like the expression of interest, that would be better for us. So yeah, if there's any technology that you would like to test, just please contact me by this email. So that is the end of my part, and we are going to move on to the University of Wollongong. So Clayton will be doing presentation. Thank you very much.
Thank you very much for that. So I'm going to start with the Warragul Shell Cove Aged Care Facility, and this will kind of tidy up the whole healthcare sector complete. And then I'll move on to the education sector wide and follow on with our ACT schools, Living Laboratories. So as mentioned, my name is Clayton McDowell, so I'm the project manager for this section of the project from the University of Wollongong's area. And by all means, feel free to contact us if you have any questions after this session or moving forward. So the Warragul Shell Cove facility is very new, state-of-the-art aged care facility. It was constructed in 2015 and opened in 2017, and they're still actually in the process of expanding into more independent living unit apartments as well. It's got a gross floor area of a bit over 9,000 square meters across 3 levels with 128 residential beds and 6 service apartments downstairs. So for this living lab though, we're going to be focusing on just level 2, which does have a range of various types of rooms in that, but they're all residential care home beds, but also has the common areas as well where they take their meals and so on and so forth. So we'll be monitoring some of that as well. So for those of you who are not familiar with Shell Cove, it's located only about 20 kilometres or 25 minutes south of Wollongong CBD. And for those that might be interstate, it's about an hour and 45 minutes south of Sydney. And it's rapid development. So they're building a whole new marina and stuff down there, which is a lovely location that's kind of developing just south of Wollongong. So this is an aerial photograph of the actual facility itself. It's got a 100 kilowatt peak solar array already installed on its roof, which was installed in 2017, and is connected to 4 Sunny Tri-Power inverters with an SMA cluster controller. And if you actually see the square in the middle here, that's where all the HVAC services are located on the roof. So this photo here is actually taken while standing up on there with all the condenser units. And for their system there, they have a Mitsubishi Electric City Multi Heat Recovery VRF heat pump system. And in individual rooms, they actually have fan coil units that deliver the cooling or heating, and they're actually able to recover that heat between different rooms, as some rooms might be on a heating mode and others might be on air conditioning mode as well, as 2-pipe system delivering both of that to the condenser units. And so each condenser services a number of rooms within the facility. And for delivering fresh air, most of this is done through an enthalpy recovery ventilator, which delivers fresh air into the corridors, but they also do have operable windows as well. This then is controlled by 2 Mitsubishi AE200 HVAC controllers, but then every single room also has their own individual wall-mounted unit, and the occupants have the ability to be able to set their ideal temperature within a band, and that band kind of shifts depending on whether it's in summer or winter. But this is an interesting area that we're actually looking at within the lab. So for our monitoring system, this is pretty much how we're running most of the UOW's components with our living lab. So we will actually have our own weather station installed on the roof that captures all the normal stuff that you expect, but also captures solar radiation as well, so we can get a better picture of that. That communicates wirelessly to a 3G router, which will have central within the facility. And we're actually using the LoRa WAN network and LoRa RAW networks to communicate to some wireless sensors that we're installing into the individual rooms that we're actually interested in monitoring. So this one here in the center, down the bottom, is the ELSIS ERS CO2 sensor. So we're capturing temperature, relative humidity, CO2, as well as occupancy and the lux levels. And so that'll be scattered throughout a number of the rooms. And then the other rooms that we're monitoring, we're capturing just temperature and relative humidity via the new bio droplet. We also have a series of watt watches, so we're collecting the energy consumption for the entire site, their solar generation, as well as all the individual HVAC devices as well, so we can see how much each individual one is using. And we're hoping to tap into their BMS system so we can also get things like the set points and that out of the system. So that's in a real tight nutshell of what the Warragul Aged Care Facility is. So we're actually in the process of installing the monitoring equipment now, and over the next 6 months or so, we'll start to gain a much better picture of what their energy consumption patterns are, how the occupants actually like to use the building itself, and what is the temperature profiles as well. We're very much open to industry with whatever suggestions that they may have with technology or services improvements that they would like to trial in a living lab like this. Some of the low-hanging fruit that we kind of see as opportunities within this facility is really a BMS upgrade to help provide some more automation, but potential central thermal storage, as well as demand-side management solutions. But for that, again, we're open and we're here to be able to evaluate technologies that might be able to expand into other aged care precincts across the country and see those benefits. So moving on to the education sector wide, we unfortunately don't have the same level of data for the schools that we do for aged care facilities and hospitals and stuff across the world, but they do have a very significant impact into our energy consumptions of our countries across the globe. So in Australia alone, we have over 10,500 schools, and you can see a breakdown here in the graph on the right of how they're broken into primary, secondary, combined, so on and so forth. And schools are actually expected to use about 8.8 petajoules of energy this year in Australia. That's based off a previous estimate from a study. So it's a very large consumption of energy. And also we're starting to see more of a cool schools movement as well, where schools previously, a lot of them were designed without any air conditioning and only covered off on heating, but so some of these classrooms are getting quite uncomfortable. So we expect this to also change as well. But we do know, looking at some of the US data, that it's about 10% of their national commercial building energy consumption for them. So it would be pretty similar for us. So we went looking for various energy consumption across the world and what sort of energy intensities were being reported by other countries, and also looked at the ones using the best data that we have here. So on the left-hand side, you can see that the kilowatt hours per meter squared, and naturally a lot of the the heating dominated countries like Canada, Finland, and so on and so forth, are where a lot of the energy is getting pushed into the heating. And this is probably typically just because we take a lot of summer holidays with our schools. So, you know, for Australia, quite often the hottest part of our season, our schools actually aren't operating, but they are operating through the winter periods. You can see Australia, though, is kind of in the middle ground here. And if we actually break it down by state on the right-hand side, again, we can see the states and territories, or territories in this case, that are in the more extreme climates of the Northern Territory or ACT is where we're actually seeing the higher energy intensity, which is to be expected. So the data that was primarily sourced for Australia was from a COAG baseline energy consumption report that was done back in a few years ago now, looking at 2001 to 2011 data. It had 1,641 schools, but the limitation there was really they didn't actually have any data for Tasmania, Victoria, WA, or South Australia. So it was some of the cooler climates there, like Tasmania and Victoria, were excluded. So we want to try and actually expand this, and we're looking at doing a survey of schools right across the nation, try and capture a point in time for their energy consumption, along with asking them several questions so that we can gain a better picture of where that baseline currently kind of sits for Australia in today's terms. But what we do have access to, so our Living Labs are actually in the ACT, and they've been kind enough to provide us with data from all of their facilities across the territory. And we're able to actually graph them out as shown here. So it's kind of broken down in various colors. The colleges are green. So for those of you not familiar with the ACT education system, they typically go with the high school will go up to year 10, and then the students will go to a college for year 11 and 12. So this first bar here is actually for a college that has a swimming pool, which is why it's probably a bit higher than some of the others. But then we also have preschools just next to it as third highest, and this is actually due to some problems with how that facility is actually heating and using gas. So some of these are some of the areas that we're very much looking into, because some of the preschools you can see are normally down the lower end of this, but the benchmark's around 80.6 kilowatt hours per metre squared for this one per year. If we break that down as well, so just some box plots here. If we're looking at really the bulk of the schools being the primary schools, the peak 10 and the high school, the medians are relatively similar. We expected to see the special schools having slightly higher requirements to have energy consumption patterns higher than what we would see in other schools. And the same with colleges, they have extra facilities, but we believe some of these preschools at this stage may be able to be shrunk significantly. So hopefully we can see this data in the next couple of years changing as we start to learn from our living laboratories as well. We see similar patterns with the gas as well. So as part of the education sector wide, and Aaron touched on some of the KPIs that we wanted to actually go into. Now this is still somewhat evolving, and we're definitely learning and gathering input from other people into how and what are the best KPIs to really measure some of these technologies as we implement them into these living laboratories. But like Aaron said, that's really broken down into the societal network and sector benefits. And then we also have the additional KPIs. So an example of some of them for the societal benefits is how much greenhouse gas emissions have we avoided by introducing that technology or service to those living labs, and really how does that actually scale out if we started to apply this to other facilities right across the country. And again, avoided air pollution as well. From the network benefits, we start looking at things like peak electricity demand, the wholesale costs of the electricity demand, the total self-consumption rate, HVAC self-consumption rate, the facility load factors, and the demand response capacity. And there's a bit of work going, especially into this section, as to how we kind of tweak this to get the most relevant KPIs out of it. From a sector benefits, we're really looking at the energy costs and energy intensity productivity. But then again, we have these additional KPIs. So if a technology provider or service provider comes to us and say, look, we've got this great idea, we'd like to evaluate it, but we'd also like to learn X, Y, Z from our participation in the living laboratory. So those are some of the KPIs we'd actually be looking to help capture that data and report on through it. And some of the key ones here is, as well as maintaining that we can keep thermal comfort at a bare minimum within that facility, if not improve it, is the ideal, as well as the carbon dioxide levels and stuff like that. We don't want to introduce stuff that will cause problems in the future. So moving on to our living labs within the ACT. We actually have 2 schools that we're analysing, but the way that the facilities are broken down, it's almost as if we actually have 4 living laboratories, and that'll kind of make sense as I go into this. This first one is Meru on the northern side of the ACT near Gungahlin. It's the largest school I've ever set foot in. It was constructed from 2004 with new buildings being added as we went, and it was fully operational in 2008. So it's got just under 17,000 square meters and over 2,000 students from preschool all the way up to year 10. As you can see from this image, there is a mighty large 600 kilowatt peak solar array, and they also have a wind turbine. So sounds like the sort of school I would have loved to have gone to, that's for sure. So looking from a top-down view, we actually have separated it into 2 key sections. So on the left-hand side, circled in number 1, we actually have the preschool section. And so we were monitoring the main building here, B12, which actually consists of 2 preschools, 2 classrooms. And this is actually one of the highest gas consumer buildings within the ACT portfolio. So we're hoping to help investigate that and come with solutions to that. as well as the other ones is B13 and B14. So these are transportables. We've added these into the Living Laboratory because there are so many transportals right across the country. They're typically poorly performing buildings, low insulation, and very much rely on their split system air conditioning units to be able to maintain those comfortable. So our idea here is we could potentially put some changes in one of them and have a mirrored facility just next to it to analyze the differences that are made between those two. The other section here is actually across here in Building 8. So this section has both primary school and high school students in it. And it is full of classrooms, just like this one here in the image, as well as science facility and some of the common areas as well. It's got a gas boiler, a bit different from the other ones, gas boiler with a hydronic in-slab heating, integrated BMS as well throughout the whole facility. And it has been designed for passive summer comfort. It's got actuated windows right throughout the facility here. However, that passive design hasn't performed as well as they'd hoped. So they've since gone through and retrofitted ceiling fans, which you can actually see in this image here. But they're now at a point where it's not enough still. And so looking at how do we actually introduce various cooling technologies. So some of the opportunities we definitely see around that sort of area. So if we actually look at the energy for this this school here, we've got a few different graphs here. The purple ones at the top is actually the gas intensity for the preschool. So you can see it's spiking here across the 2017 period. We're hoping that it's now returning back down to these levels, but even still, both the gas for the primary school and the preschool are still very, very high. And you can see again, it's that predominantly winter heating. But like I said, with cooling being introduced, we're going to start to see changes between the December through to January, February sort of periods, or at least when the schools are actually in class. Very similar to the Warragul Shellco facility, we're installing mostly the same equipment. So it'll have its own weather station, as well as using the LoRa WAN, LoRa Raw network to collect a lot of the data points individually throughout the monitored rooms, and what watches as well for the electricity. What we are, however, adding is down the bottom right here, the new Bio Micro Edge. So this actually has a pulse counter and a 0 to 10 or 3 0 to 10 inputs. So we're going to be using this to actually capture the gas usage throughout their facilities, as well as capture the water as well. So how much water is going through those heated slabs and what the temperature is going in and out of those loops. Again, we also hope to capture whatever we can from their BMS system as well. So all that's in process right now. So some of the opportunities, again, here, we're very much open to industry coming to us with any suggestions that they have with technology and services they would see fit within these sorts of facilities. But really, is it possible to look at replacing this heat pump, the gas boiler with a heat pump? Because that may be able to deliver both the heating and cooling needs using the already slab, water-cooled slab. BMS upgrade as well. So how do we actually take a better effect of using some of these systems that are already there and put them to a bit better use with maybe some model predictive control or something. Central thermal storage again, and some demand side management solutions. If we go further down south of Canberra, we come across a little primary school called Fadden. This is a bit different from the Meru facility, which is built during new environmental and efficiency standards, where this was opened in 1984. So it predates any of the changes with environmental and sustainability measures. It's got a gross floor area of only a bit over 3,000 square meters. It's got 280 odd primary school students, and it has a small 10 kilowatt peak array located here, but they are currently exploring options to potentially expand this to a much larger system across it. So for this building, for this school here, the Living Laboratory is actually going to be the majority of the school, and that's predominantly driven by the fact that they have a gas boiler that provides heating to the entire school system. So by monitoring that, we're actually capturing the heating consumption across all of these facilities that are actually highlighted in red. Now, this central gas boiler is the original gas boiler. We're hoping it gets through this winter. And one of the opportunities for this Living Lab is really to replace that with something that would be electric and be able to deliver the needs to this facility. So they're driven through some air handling units in each of the classrooms. You can actually see as well the little squares with the shadows on the roof. So these are evaporative coolers that have since been introduced to the learning areas at a much later date to when the facility was originally built. And they've now started putting in split system reverse cycle air conditioning units in some of the staff rooms as well. But it's the classrooms that we're very much driven to seeing how they perform. So the only building that we're really excluding is this one at the top. And the preschool we're not including in this, so it's just a primary school primary component. Again, if we look at their energy data here, its intensity is much lower than what we see at Meru, 14 kilowatt hours per meter squared compared to upwards of 40 at Meru. But when we start looking at other metrics like the kilowatt hours per student, Fadden's actually much higher than Meru. So these KPIs really have to be looked at from multiple different angles to see how it really is performing. But we do see this winter-driven profile again. So it's a cool place. The monitoring system there is exactly the same as Meru. The only difference that we actually have here is we've removed the BMS system down here. So there is no BMS system that's installed within Fadden. So we see that as a potential opportunity. They are in the process of trying to install some more sensors and seeing what control we can kind of gain out of that. But that's very much early days and we're not there yet. So we see that as a great opportunity as well. So some of the opportunities, again, with Fadden. So this gas boiler, it's very much past its use by date. And so looking at opportunities on what is the best and latest technology that would go in here that would benefit a lot of this old school stock that we see in places like the ACT that where we have these gas boilers that are kind of at their end of life. Some BMS upgrades as well, the way we could possibly get some automation in there and better connect it to how the solar is performing. Central thermal storage, again, demand side solutions, but this is not an exhaustive list. We're very much open for any suggestions. So I just wanted to really finish off with why participate or some of the benefits for participating in a Living Lab. So this kind of provides the opportunity for technology or service providers to actually have independent and rigorous testing done on whatever they're actually wishing to install. But that's also using some of the funds from this iHub project as well, funded through ARENA. So we do have capacity here to actually help fund some of the contracting of the installs and removals, but looking at people to actually provide the products themselves for us to evaluate. These Living Labs will be running for the next 2 years, so it'll end in June 2022. But we have plans to keep these Living Labs going for much longer than that, as is our main goal. But definitely over these periods, we have the capability of providing the technology reports on these tested texts through this period. But the other thing is it really gives the technology and service providers out there the opportunity to demonstrate your technology in these sorts of education and healthcare facilities. So really demonstrating how we could use these sorts of methods to reduce energy demand and increase their bang for buck, their value of their renewable energy systems that they're installing. Now, both in the education and healthcare sectors, there's a large amount of buildings right across the country. So being able to have that case study proving its effectiveness will definitely help to hopefully improve not just those facilities, but also you as technology and service providers as well in your core products. So how to get in contact with us. All of this information is going to be available to be viewed again online, but this is our main page here. So you can either go through iHub directly or feel free to contact any of us listed on this list here. And we're more than happy to have these conversations around how we can see about getting your technologies or services tested in one of these Living Labs. So that's it for me. Thank you very much.
Thank you for that, Clayton. So if anybody does have any questions for any of our presenters today, please use the Q&A function and we'll go through any questions that you may have.
I'm happy to jump in on Paul's question there from our side of things. Are the facility managers keen to take on board the advice and guidance we are providing? Yeah, absolutely. We have an amazing relationship that we've been spending quite a bit of time building within not just Warragul, but also all the individual schools, and not just with the people that are the high decision makers, but the engineers and that on the actual ground that are working with these equipment and other ones that have to maintain them and operate them on a day-to-day basis. And we're trying to involve them within all the decision processes. So if we actually have someone come forward with a technology or service that they wish to provide, these facilities will be very much involved with those discussions on how they see it fitting best and having input into that. We're having, I think we're trying to build a long-lasting relationship, not just within the 2 years that we have here. So.
Thanks for that, Clayton. We've got a question from Ben, who's asking, are there any restrictions on potential technologies to be used? If any of you guys want to step in on that question.
I can try to attempt from the Queensland Children's Hospital Living Lab point of view. First, we will welcome all technologists to start having discussion or initial meetings, and we do have a risk assessment process to follow for both our university point of view and also from the operation of the hospital point of view. If we really want to talk about restrictions or something could not happen, as possibly maybe, for example, clinical related research, we cannot do that. That's what I can think. But otherwise, the building energy efficiency, material, retrofitting, HVAC related technologies, or renewable energy technologies, so we all welcome that.
Great, thanks for that, Aaron. Clayton, I think Paul has stepped in there, just expanded on your previous question. If you don't mind, just replying back to Paul there, Clayton.
Yeah, sure. I guess in a summary, yes, we're trying to connect with industry wherever we possibly can, to not just, one of the big things as well is not just how we actually applies in these living labs, but how that expands out to those sector-wide projects. So that sector-wide section is definitely where we're looking, well, I'm just trying to get to that question, where we're looking to see how we can see these and use these studies to actually get a better understanding of that. But absolutely, and by all means, feel free to contact us. We'd love to talk to you in more detail.
Thanks, Clayton. A couple of other questions are also coming through, guys. There's another one there from Greg, who's asking, are there zero combustion solutions at these sites with current technology? Not sure which one of you want to hop in there.
What does it mean by zero combustion solutions? So maybe I need to understand the question slightly better. Great.
I think what he's asking is, are there zero combustion solutions at these sites with current technology?
Like a non-emission type of heat supply, or like electrical?
I'm not sure, Aaron. It hasn't stated specifically what it is. Oh, he's just written no natural gas.
Oh, okay.
Thanks for that, Greg.
Yeah, for Queensland Children's Hospital site, that they use gas and diesel. So don't have electrical heating yet.
I could take that one if you like, Marie.
Sure, thanks.
Yeah.
Thanks, Mike.
For Warragul, aged care, for example, they've got, as Clayton mentioned, 100 kilowatts of solar PV on the roof and no natural gas on the site for HVAC at all. So it's all the Mitsubishi Electric heating condenser units for heating and cooling. So that's quite a new site with no combustion at all. Yeah. So we'll be looking at the performance there.
Just adding to that, so Michael Tibbs, who just answered that question, is one of my colleagues with the University of Wollongong, working on both of our living labs. But also looking at from the school side of things, the ACT in general has a very big driver to go full electric across the territory. So how to actually get these schools to be 100% electric is a big key for us moving forward. To also go on to Paul's further questions, we are capturing some post-occupancy evaluation questionnaires throughout the process. However, the living labs at this stage within our scope, we're not actually tracking learning outcomes or health outcomes of the occupants. We have looked at some of the health outcomes in previous studies for aged care areas, actually with Warrigal in previous studies. For the schools, we have got other projects that we have been investigating, trying to do these sorts of things, but it's outside of the scope of the living lab right now within this scope. But like we said, after 2 years, we hope that there's a longer life with these living labs where we continue to use them to make learning outcomes, and potentially that's one of them.
Maybe let me touch on this slightly, if it's okay. For Paul's question about health outcomes linked to better comfort and indoor air quality, that for our Fern Hill aged care facility, we do plan to work on some parts of it, and we are planning for example, ethics approval. So we would be investigating, maybe not a whole lot of time, not the whole project of 2 years. But later next year, we plan to do research on that point, but we haven't started.
Yeah, just to continue on what you're saying, Aaron. So yeah, we are definitely planning to do some analysis on the indoor air quality and the adaptive comfort at Fernhill. In essence, because it is designed to provide natural comfort. So we already are planning to install like all types of sensors related to temperature and relative humidity. We are also planning to do some interviews with the occupants in terms of how they operate the buildings and how, like, what time do they open, close the windows, and what time do they rely on air conditioning, what times on ceiling fans. We are also planning to develop something that is called a portable IEQ card. So it's basically it's a card that encompasses the current temperature and relative humidity, so the current conditions, indoor air quality conditions, as we do the interview. So we can ask questions and know the impact of the current conditions on the perception of comfort of the actual occupants. So yeah, there is definitely room for analyzing things that are related to adaptive comfort and indoor air quality in Fernhill.
Great, thanks for that, guys. I think that's all that we've sort of got at the moment, unless you guys have anything else that you guys would like to add to the group.
Maybe Clayton, I was wondering for the wind turbine at school.
Yep.
That was interesting. Of course, it's amazing school from the plant, 600 kilowatts peak solar PV. That was wonderful. But why a wind turbine? Or I didn't see it in the picture. I'm an electrical engineer, so I'm quite interested in that.
Yeah, why? Yeah, good question.
How? Yeah.
I don't have an answer as to why they have wind turbine there. I think from a learning perspective, it's amazing to be able to, like, sustainability is getting brought into a lot more school curriculum. So being able to have that stuff on site, I think is fantastic, which is why, I said I would love to have studied there myself. The school I actually went to is just south of Fadden. So that was built in the mid 80s. But yeah, I'm not 100% sure why they chose to install one there, but I can try and find out in the future.
Oh yeah, thank you. Yeah, I know that normally or sometimes that people find out in some places like the coastal area, for example, the Australia coastal areas, that the wind turbine kind of can work when the solar is not working, like the off solar hours, that we tend to have more wind resources available in the sunset or sun-rising time or overnight. So I'm not sure if that's a consideration. Thank you.
Well,
yeah.
for the
Talk to you
schools
later.
at, they finish school around 3 p.m. So they have a very interesting load profile, which is what we want to learn from, is how we can actually use some of these systems after the schools have actually finished for the day, to how that affects the grid locally as well.
Yep. Thank you.
So I think that last question there, do you survey occupants' satisfaction? We will be performing post-occupancy evaluations before and after the technology installations as well, so we can get a survey on how that kind of has affected their perception of it.
Thanks for that, Clayton. If anyone has anything before we wrap things up, any last questions for our presenters, please send them through. If not, we can wrap things up there. So thank you all, everybody, for attending today's webinar. Many thanks as well to all of our presenters today. As you guys are aware, this is the third and final webinar for the iHub webinar series. The recordings of each webinar will be made available up on the iHub website and also on the ERA webinar website page. And we will send out an email letting you guys all know when that does become available as well. If you want any more information regarding iHub, please visit the iHub website, which is ihub.org.au. And again, thank you all for attending today. See you later.
Thanks,
Thank you.
Mary.
Bye.
Thank you, Mary. Thank you, guys. Bye.